Greetings and welcome to my new calculus channel. My name is John Gabriel. So, I can't tell you how many times I've been asked this question. I would like to understand your proof on why the auxiliary equation goes to zero. Well, first of all, the auxiliary equation does not go to zero or anywhere else. The auxiliary equation is always zero. And I'll explain why in a moment. So in the new calculus, a secant line, this is the new calculus, and this is a secant line that is parallel to a tangent line, right, is used to find the tangent line slope. In the new calculus, we never care about what happens there. Okay, doesn't matter because I always use the slope of a parallel tangent line, which is equal to the slope of a parallel secant line, which is equal to a parallel tangent, right? How do I know that I can always find a parallel tangent line? Well, Euclid proved that over 2,400 years ago. What did he prove? He proved that from any point not on a line, we can draw a line through the point that is parallel to that line. It's in one of the propositions, and of course, because moronic mainstream math professors have never studied these things, they haven't been able to tell you. So. Um, since the expression in M and N is the difference in slope between the parallel secant line and the tangent line, it must be zero. Because why? Because parallel lines have the same slope, you idiots. Okay, so if you take the difference, it's zero. It's elementary algebra. That's why the auxiliary equation will always be zero. And I'll get to what the auxiliary equation is in a moment. There's no proof required. This is as simple as proving that parallel lines have the same slope. Okay, now let's get to this diagram and explain a few more things. So how do these things work? Let's see the calculations. So this first states the equation of the auxiliary equation in terms of the cubic. So I've used the cubic for both the new calculus example and Newton's calculus, which is on the right. Okay, so in Newton's calculus, you have to use my historic geometric theorem, which basically this. Okay, this expression here. So let's just see if we can put a little. It's this. Okay, this is my historic geometric theorem. And there's a link in the details section which you can read up on it. So, and then of course, what I do is I compare the two. So if I move these along like that, notice that the new calculus auxiliary equation is always zero, all right? And notice that the mainstream calculus is never zero. Okay, so watch this. Okay, always zero in the new calculus, always zero in the new calculus, and never zero in Newton's mainstream calculus. Okay, so the only time it's zero is when it's there, and then you have a problem because the difference quotient, this difference quotient is no longer defined there. It gives you what your bullshit mathematics lecturers and teachers tell you, an indeterminate form. There is never an indeterminate form in the new calculus because you don't have this in the new calculus. Okay, that's just garbage. You're always dealing with the slope of parallel, and if you do this, there is no more parallel secant line. So how can you expect to have a slope for a parallel secant line there? There isn't one. Okay, but still, because it is so well formed and well defined, when you do this, you'll still have the derivative, and you can just ignore the terms in n and m, right? Because they don't matter. They're the difference. So that's what happens when you use well-formed concepts. You end up with ideas that work. Now, on both sides, the new calculus is based on the mean value theorem, which is a reason why calculus works. So it relates these distances. It relates this distance m and this distance n to the point of tangency. You have nothing like that in your bullshit mainstream calculus. All you have are approximations. All you're doing is this, and you never have the finite difference. Okay, you have to imagine it as some limit. Okay, right. So I'm sure all of you know that in your bullshit calculus, you simply say f of x. Let's get a pen here. You simply say f of x is equal to lim as h approaches 0 of f of x plus h minus f of x over h. And this is never defined. Never, never, ever, ever. Okay, it's total BS. You just don't have it. There is no finite difference. There is no finite difference like that. All right? So let's just clear that out there again so that in case we need to write, we have a space to write. As you can see, I've just written the equation or the expression for q of xmn, which is always 0 because I've put the values in here and I'll show you it's always 0, right? And it doesn't matter where you are. You can be over here. Let's put it over here and here. Okay, let's put it on 3 if we can. Oops, is it on 3 there? Whoop, almost. Okay, well, yeah, I'm 1.5 actually. I'm trying to get 1.5, yeah. Let's see here, 1.5. Nah. All right, well, I think you know what I'm talking about. And as you can see here, we always have 0 for the new calculus expression. Doesn't matter where we are. Now, the only difference between the new calculus and the bogus mainstream calculus is that there is no tangent line at a point of inflection. So if you do this, you don't have a tangent line in the new calculus. You don't have either a tangent line or a parallel secant because it's an inflection point. Okay. That doesn't mean that you don't have a general derivative there. You will still have a general derivative. In other words, you will still get this value 3x squared. Okay, you'll still get that value, even if you don't have a tangent line. So, I mean, if you don't have a parallel secant line. So if you really want to have a derivative at a point of inflection, you can, even though there's no tangent line there. It doesn't make sense because there are only half tangent lines at a point of inflection. It's not a true tangent line. Okay. So, and of course, from the historic geometric theorem, we see that q of xh down here is never 0. And of course, the only time it is ever 0 is if this blue function, which is a cubic, is a straight line. That's the only time you'll have q of x. And that makes sense. Why does that make sense? Because then this here is the rise over run function. If it's a straight line, if it's a straight line, you're not going to have this. Okay. You're not going to have this. Let me just get rid of that. You're not going to have this. Okay. If it's a straight line. End of story. That's the only case where you don't have it. So then, of course, a lot of the mainstream libelers like Jack Hazinga and all the fucking morons that didn't understand this, they basically missed the entire point because they never got past the derivative. But if you get past the derivative, you'll see that the new calculus integral is also very well defined. It's this. It's just simply the derivative at x multiplied by the interval width. And the same thing happens with the historic geometric theorem, which, by the way, you didn't know this in your mainstream calculus. I revealed this to you, okay? The great John Gabriel, the genius John Gabriel, revealed this to you. Not the fundamental excrement lemma or anything else. I revealed it to you. So just remember that. Okay. So, and this here is not as good as the new calculus, okay, because you've got this wretched difference here, which is always here unless it's a straight line, okay. And so you have both a clear definition of the derivative and the definite integral. Now notice I could have written inside here. I could have written inside here. In this here, I could have said plus. Oh my God, this always happens. Stupid GeoGebra software. Okay, I could have written plus q of x mn like that. Okay, I don't have to because why? It's always zero. See, it's always zero. I mean, it's okay if I write it in, but then I know it's always zero. All right. So let's see if we can just delete that. Bye bye. Okay, and that. Well, I'd have to move this out of the way to delete that. So I can write this using the difference or not, but this will still give me, it will still give me what you see here. It will still give me the derivative plus the auxiliary equation expression. And of course, I can always set this expression here to zero because it is always zero. So do you understand the auxiliary equation now? Whoever this is that asked me, this RDK6842, okay, that's basically everything you need to know about the auxiliary equation and about the definitions for the new calculus derivative and integral. So let's get rid of that. As you can see, it doesn't matter where you are, you will always get zero. Okay. There's no difference from any particular point. The only time you will not have uh, a tangent line is at a point of inflection. And here, even though you might have a tangent line, it's only half tangents, and you still have a difference. See down here, you still have this difference from the mainstream calculus. It's still not correct. But the new calculus is rigorous. Unlike Newton and Leibniz, who were monkeying around trying to find the slope of the tangent line, I didn't monkey around. I thought about these things clearly, like my ancient ancestors, the brilliant Greeks, thought about these things. There's no guessing here. I didn't guess these things. That I used a parallel secant line is ingenious. Okay, nobody thought about it before me. Not a single human. I was the first. The brilliant, the great John Gabriel. I don't give a shit whether you hate me saying that. I'm telling you, that's a fact. And if you don't believe it, well, it makes no difference because what I'm telling you is true. And the majority of you are morons anyway. So I'm bound to get a lot of moronic comments on this video, which I'll just delete, and I'll block you. By the way, there's a price you pay if you post a comment that is idiotic. You simply get banned from my channel. You don't want that because you want to be able to write comments on my channel. So you be respectful, you little shits. I'm 62 years old, and the majority of you weren't even born when I discovered these things. Okay, including that fucking idiot Jack Hazinger. Now, the one that was born just turned out to be a rotten, screwed up fool like Gilbert Strang, who tells you things like, "Oh, it's essentially the same as calculating zero over zero in in the bogus mainstream calculus." No, you don't calculate zero over zero. There is no zero over zero. To say zero over zero is meaningless nonsense. You don't write that. There is no indeterminate form. If you call that an indeterminate form, you're implying somehow that it's valid. It's not valid because zero is not a number. For the 1,000, for the 1 millionth time, zero is not a number. I don't give a shit who told you. Even if God told you, I tell you to go tell God to fuck himself because God's an idiot in that case. Of course, God would never tell you that because God is the most brilliant mathematician. Okay. So, or the gods, whoever created the universe. I don't believe in evolution. It is a theory full of holes. And by the way, don't put a comment in my channel about evolution. I'm not interested in discussing it with any of you. You're way below my intelligence. Don't you dare put a comment on evolution. It'll just get blasted away and you will get banned right away. Okay, you're all flat earthers. Okay, that's what you are, because when you're presented with overwhelming evidence, you have the chutzpah to open your sewer mouths and pretend that you know better than me. You don't know better, you morons. If you knew better, you would have discovered these things before me. But you didn't. Neither did your fathers or your miserable, idiotic ancestors. On the other hand, I have a claim to genius. The ancient Greeks, whose clarity of thought was never matched by any before them or after them, I am one of their descendants. Okay? I don't give a shit what you think. Fuck you, whoever you are. Don't you dare tell me that you know better. You don't. You're a moron. You're an idiot. You're an ignoramus, especially if you're a set theorist or some nincompoop or poople who thinks he knows about mathematics and logic like Zelos Malem or Marcus Cliver or Terence Tao or any of those fucking idiots. You're all morons. That's the truth. I'm giving you the facts. I'm being straightforward with you. Okay, yes, I don't have diplomacy, but you know what? Up yours. So, those who are interested in learning the truth, I'm addressing you now, and I'm back from addressing the fucking idiots. This is priceless knowledge which I have given to the world. In return, they have destroyed my life. There's kind of a pattern here. They did the same with Greece. Greece gave the world Western civilization. Look how many times they tried to destroy Greece, but Greece is still around. It may be one of the poorest countries, but it's still around. I guess that says something, doesn't it? Well, I wish I weren't in this predicament because theoretically or morally, the whole world should be paying copyright to Greece because everything you have is a result of what my ancestors did. You wouldn't have had nothing. You would have had computers. You wouldn't have had rockets. You wouldn't have had anything. That's really what it boils down to. So you should all be contributing to me, even if it's just $10, $15. You should make sure that I have a roof over my head and food to eat because I've given you this for free. Nobody else has told you these things. I mean, your moron fathers and mothers and grandfathers and grandmothers, they're all idiots. They don't know these things. And they are important. And there is a crisis in calculus education. Why? Because your calculus is based on bullshit, ill-formed concepts. If you're not already a subscriber, become one. Click like, by the way, those who support me. Remember always to click like. If you don't, they'll vote the video down and others won't get to see it. So they're killing the messenger. That's what the fucking morons of mainstream are doing. They're killing the messenger. In fact, they've already killed me for all intents and purposes. And follow me on academia.edu, to which I'll place a link. I'll also place a link to this applet for you so that if you feel like playing around with it, you can. And if you have any further questions, whoever asked this, go ahead and ask the question and I'll try to answer. My name is John Gabriel and this is a new calculus channel. Till next time, goodbye.